Hello astronomy and physics students. In this video we're going to take a quick look at escape velocity, both the basic concept and the math behind it. The basic concept is very easy. Say you're launched off of an object, whether that's a moon, a planet, a star, and you go upwards. Basically the question is, how fast do you need to be moving so that you never actually fall back down to the surface, but you remain in orbit around whatever object? The math is very simple. It's all based on energy. So any object that's moving has kinetic energy, and what's trying to pull it back down and balance that is the gravitational potential energy. The equations for these are like so. So for kinetic energy, the moving energy of any object is going to be 1/2 times the mass of the object being launched. So that was our little rocket or our spaceship up here, times the velocity squared. And on the gravitational side, gravitational potential equals big G, the gravitational constant, times the mass of that same small object that was being launched. And let's use a big M to represent the mass of the planet or the moon or the star. And all of this is divided by the distance between the object being launched and the center of the object it's trying to get away from. And now we're just going to do the math. So let's go ahead and simplify first. See, we have the mass of the small object on both sides. It simply cancels out. So we're going to have 1/2 v squared equals g big M over r. And we're just going to keep going until we solve for the velocity to see how fast we're going to need to move in order to get away from the gravitational pull of this object. So let's multiply by 2 on each side so that these cancel out. Now we have v squared equals 2gm over r. There, I'm out of room, so let's go ahead and copy that to the top of a new page. And now we're just going to take a square root. And we end up with the escape velocity equals the square root of 2gm over r. And that's the escape velocity. So as long as I know the mass of the object I'm trying to get away from and the distance at which I'm starting my getaway, right here and right here, as long as you know those two things, you can calculate how fast you need to move in order to escape this object.